Have you ever just looked up at the sky and thought about what's actually hanging over our heads? I mean, every single day we've got these massive structures up there casting shadows, painting sunsets, and holding literally millions of tons of water. To put that into perspective for a second, an average cumulus cloud weighs over 1,000,000 pounds. Yeah, 1,000,000. That is the equivalent of 100 elephants just floating effortlessly right above you. We see these majestic things all the time, but how exactly do they get up there? What are they really made of? Well, today in this explainer, we're going to dive deep into the genesis of clouds. We'll break down the fascinating journey that water takes from the literal ground beneath your feet all the way to the sky above.
All right, let's dive right in. Now, to really understand the sky, I actually want you to start by picturing something right in your own home. Imagine you're standing in your bathroom and you breathe heavily onto a cold mirror. What happens? Boom! Almost instantly, a patch of tiny liquid droplets appear right there on the glass. But where do those droplets actually come from? I mean, they didn't just magically appear out of nowhere, right? The invisible water vapor that was already in your breath hit that cold surface, it cooled down incredibly fast, and it transformed into tiny, visible liquid droplets. And as you're going to see today, clouds form in almost exactly the same way. It's the exact same simple physics, just happening on this massive planetary scale.
So let's kick things off with step 1, the invisible journey upward.
Let's shift our focus from that bathroom mirror to the entire planet. Because every single cloud you've ever seen begins its life down here with us at ground level, embarking on a trip that we literally can't even see with the naked eye. The absolute crucial point here is that this journey starts with heat. The sun acts like this giant cosmic engine, beating down and heating up water sources all over the Earth. And it's not just the massive oceans, though. Obviously they play a huge part. It's also lakes, winding rivers, and yep, even the wet soil in your backyard. Plus, there's a really cool biological factor at play too. A process called transpiration, where plants and trees essentially sweat, releasing massive amounts of water vapor into the air. So when the sun's energy hits these ecosystems and bodies of water, it causes the liquid to undergo this fundamental transformation. It changes state entirely, turning into a gas.
Now, you might already know the word for this. This transformation process is evaporation. Water changing from a liquid into an invisible gas, which we call water vapor. The key thing to remember here is that it is entirely invisible. Unlike those fluffy white clouds we eventually see, water vapor is completely unseen. In fact, right now as we speak, there is water vapor floating in the air all around you, starting its upward journey, and you can't even see it.
Which brings us to step 2. Warm air rises.
This is a super basic rule of physics, but it's literally the engine that drives our weather. Warm air is physically lighter than cold air. When the air down near the ground heats up from the sun, it has nowhere to go but up. It becomes buoyant, and it carries all that invisible water vapor right along with it into the sky. And then, an invisible chain reaction occurs as this warm, vapor-filled air travels higher and higher into the atmosphere. As the air rises above the Earth, the air pressure around it decreases, and because there's less pressure pushing in on it, the air naturally expands. And here's the secret to the whole process, a scientific phenomenon known as adiabatic cooling. As that air expands, it naturally cools down. This is the exact same concept as your warm breath hitting the cold mirror, but instead of a piece of glass, the air is just cooling itself by expanding high up in the atmosphere.
All right, step 3. Condensation begins.
Okay, we're zooming right into the microscopic level here. The rising air is expanding, it's getting colder and colder until it reaches this specific tipping point where it becomes way too cool to hold all of its water vapor. The rising air basically hits a critical threshold. The excess water vapor has to go somewhere, right? So it changes back into tiny liquid droplets. This process is condensation. It's the exact opposite of evaporation. The invisible gas transforms back into physical liquid water. So our mirror analogy strikes again. But wait, up in the vast empty sky, there's obviously no glass mirror for the water to collect on. So what do the droplets grab onto?
Well, to actually form, these water droplets absolutely require something solid to cling to. We're talking dust blown up from deserts, sea salt whipped up from ocean waves, or even smoke from fires. These tiny microscopic particles floating way high in the atmosphere are known as condensation nuclei. The cooling water vapor condenses directly around these tiny specks to create physical droplets. And here's a totally wild detail for you. Without these tiny specks acting as an anchor, the relative humidity in the sky could literally exceed 100% and a cloud still wouldn't form. How crazy is that?
And that leads us to step 4. A cloud appears. So let's put it all together. We've got rising warm air, we've got cooling temperatures, and we have microscopic liquid droplets forming around tiny specks of dust and salt. But, one microscopic droplet isn't nearly enough to see from the ground.
However, when billions of these extremely small droplets gather together in the exact same patch of cool atmospheric air, well, that's a cloud. That is exactly what you are looking at when you gaze up at the sky. Packed densely together, they reflect a massive amount of sunlight back into space, which, by the way, is called the albedo effect, and that's what makes them appear bright, vivid white. And hey, remember that million-pound weight we talked about at the very beginning? That is the collective mass of all those billions of microscopic droplets you're seeing.
So at a fundamental level, a cloud is just a floating collection of tiny water droplets, or if it gets cold enough, ice crystals. They're just gathered, microscopic droplets clinging to dust and salt, packed so densely together that they catch the sunlight and become visible to us all the way down on the ground.
Moving on to our final phase, Step 5, how rain finally falls.
Because a cloud story definitely doesn't end just by hanging out in the sky. It is actually an incredibly active, dynamic environment inside. Inside the cloud, those billions of tiny droplets are constantly swirling around. And as they swirl, they collide. When they collide, they merge together and grow larger and larger. What's actually happening here is an intense atmospheric tug-of-war. You have the powerful updrafts of warm air trying to push the droplets higher, battling against the downward force of gravity trying to pull them back to Earth. Eventually, these merged droplets become so large and so heavy that the rising air simply cannot keep them suspended anymore. Gravity wins out. They fall out of the bottom of the cloud. And depending on the temperature on the way down, they're going to fall as liquid rain, fluffy snow, or solid hail. In science, we call this entire downfall process, of course, precipitation.
Let's take a look at the shapes in the sky. Now that we know exactly how they're born and how they end, let's zoom back out to the macro level. Because atmospheric conditions are constantly changing, different temperatures, different wind speeds, different amounts of moisture, these atmospheric collections can take on very different forms. First up, we have cumulus clouds. These are your classic, puffy cotton ball clouds that usually mean fair weather. Then we have stratus clouds. Think of these like a big continuous blanket. They're flat, layered clouds that often cover the whole sky and make it look completely overcast and gray. Finally, we have cirrus clouds. These are the wispy, very thin clouds located extremely high up in the atmosphere. And because it is brutally cold up there, they're actually made of ice crystals rather than liquid droplets.
Okay, let's quickly recap this whole amazing chronological journey to permanently lock it into your memory. It starts when the heat from the sun causes evaporation, turning liquid into an invisible gas. That warm, invisible vapor rises, expands, and causes adiabatic cooling. That cooling triggers condensation, where the vapor turns back into tiny droplets around specks of dust and salt. And finally, billions of those droplets gather together, and boom, a massive cloud is born.
I want to leave you with this final, honestly beautiful thought from the explainer today. Every cloud in the sky began as invisible water vapor. What you see floating overhead is simply water taking a temporary journey through the atmosphere. Every cloud is essentially just a temporary river in the sky. But as our planet's temperatures rise and evaporation accelerates globally, how will these invisible journeys change the maps of our future? Something to think about next time you look up.